Joe Hezir, thank you so much for having me at the Energy Futures Initiative here.
Well, thank you. I'm glad to be here and glad to have you here today.
Yeah, so you're the managing principal. I guess that means what? You run the show day to day here?
Yes, I do. I run the show day to day. A lot of it's due to the fact that I'm the one who's in the office the most. My two fellow principals are traveling a great deal.
Well, I'd love to hear the story about how you guys got all connected, but first I'd like to just hear about you. I mean, I know you spent a ton of time as the financial guru, both in the White House and at the Department of Energy, but where did it all begin? Where did your interest in energy actually begin?
Well, I guess it really goes back to my undergraduate college time when I was in chemical engineering and started taking an interest in environmental control technology issues, and then from there getting involved in energy. And my interest in technology quickly moved from the technology side to the policy side. And that's how I really got interested in it. Although my first job in government really was in the environmental side, because I had experience as an environmental research engineer and was looking for a position here in Washington with one of the agencies, and there was a position that opened with the Office of Management and Budget. And at the time I was not particularly interested in budgeting, but they were interested in somebody who could come in who had experience as an environmental engineer. So,
and what did environmental engineers do at the time? What was the bread and butter of that industry?
Well, I was doing mostly research work on pollution control technology. I had worked for a large corporation looking to address some of their hazardous waste cleanup issues, and doing some laboratory research on different techniques for how they might change the operation of their plant. And then later on, I was on the staff at Carnegie Mellon University, where we were doing research work for the steel industry, trying to develop some new technologies for them for air pollution control.
So steel, in addition to chemical waste streams, it's also got air waste streams as well?
Yes, this was looking at air quality issues associated with blast furnace operations.
Wow. And is that the basic division when we look at waste products that go into the environment? We look at what goes into the air, what goes into the water. How would you characterize it? How do we think about these issues?
Well, I mean, clearly all of these processes have, put it in technical terms, residuals, and whether they're discharged to the air, water, or solid waste. And with increasing recognition of the environmental and health impacts of those discharges, this led to increased efforts at environmental protection. And from a technical standpoint, then that's just sort of created a new set of challenges for people in the engineering field to find ways to either modify those processes to reduce the amount of emissions, or to find ways to clean up those emissions before they enter the environment.
Is everything accounted for, or is it just the things that we tell companies they have to keep track of because it might pose some sort of chemical hazard or toxicity that they actually account when they dump things into the environment?
Well, I think that, looking over past decades now, environmental regulation has become very sophisticated, and I think there are now a number of requirements for companies to monitor, to report, and to control. And so they are addressed in a very comprehensive manner.
Yeah. And so you came into the Office of Management and Budget because you had this experience. What did they want you to do then?
Well, this was 2 years after the enactment of the Federal Water Pollution Control Act amendments of 1972. And there had been not a whole lot of activity yet on implementation, and it was just beginning to enter the implementation phase. And there were many, many new federal programs that were authorized by that act. And so there were many questions about the budgeting for the Environmental Protection Agency, which was charged then with implementing the act. And so I was involved in not only reviewing and preparing the budgets for a lot of the clean water programs, but also in reviewing the early regulations that were being issued by EPA under the act.
I mean, you say reviewing. What were you looking for?
Well, the Office of Management and Budget, in addition to its budgetary oversight role, also has a government-wide regulatory oversight role, where it is charged through a series of executive orders and now by a statute to review proposed government regulations to make sure that the cost of regulations that are imposed on society are justified by the estimated benefits, that the regulatory approaches that the agencies are taking are the most cost-effective approaches, that regulations are streamlined as much as possible. And so the idea of having the independent review is to kind of serve as a check to make sure that indeed that federal government regulation is as efficient as possible in accomplishing the statutory objectives that are set forth for those regulations.
And then are there, just depending on the administration, different swings of when you go heavier towards enacting more regulations, and how you run that calculus of, are these regulations worth the benefit of society, or are the costs too high, swinging in the other direction? Does that happen over time?
I think over time there has just been a gradual trend to have increased independent scrutiny over federal regulations, irrespective of presidential administration. And the reason for that is that, again, if you look back over several decades now, the scope of federal regulatory authority has expanded greatly. So there has been increasing concerns about the costs being imposed on society, and to make sure that those costs are justified by the benefits.
And is there a good way to value this? I mean, do we just look across society and say, yes, it's good to impose a cost with regulations on any given industry to make sure that they're cleaner and pollute less in the environment, but then do we look at the net effect and say, but if this chemical is twice as expensive as it was before, and that chemical goes into medicine, maybe we're doing more damage than good because people can't get medicine at a cheaper rate. I mean, do we look across the entire net effect of any given industrial process and view it holistically?
I would say not on a regular and consistent basis, but there have been various periodic efforts to take a systematic review of regulations. For example, there have been several periodic comprehensive reviews of the Clean Air Act, because under the Clean Air Act there are many regulations, and to look as a whole, what does the Clean Air Act accomplish in terms of health and environmental benefits versus what costs that is imposed on society. And so there have been some of those, but not. It's a very expensive and a very extensive process to do that.
Yeah. And then how does it actually work? If it's the Clean Air Act, I guess Act means that Congress issued this. And then what role does the executive branch then play, other than this review and oversight? What if they review and find something isn't exactly how they wanted? What is the give and take of the two branches of government in that sense?
Well, in a lot of the environmental statutes, Congress has granted broad authorities to the executive branch, primarily to the EPA. And so the EPA does have wide latitude in fashioning regulations. There are certain statutory touch points or requirements that they have to meet. But how they regulate, they have a lot of discretion. And so that's where a lot of the technical, scientific, and the economic analysis comes into play to find the right combination and the right approach to setting those regulations.
Yeah. You were there at the Office of Management and Budget for almost 20 years under a couple different administrations. What jumped out at you the most during that time?
The thing that I thought that really was most interesting, that I think that is that OMB plays a very important role behind the scenes, because again, as government has become more complex, there are more issues that arise of an interagency nature. And OMB, in the hierarchy of the executive branch, is the first place where the interagency issues begin to come together in one place. And so OMB plays a role in coordinating and in some cases refereeing interagency issues.
What's a specific interagency issue that you remember?
Well, one of the early ones that I worked on had to do with regulation of wetlands, where the authority to issue permits for activities that affected wetlands was vested with the Army Corps of Engineers, but EPA was responsible for issuing the guidelines, the environmental guidelines that the Corps of Engineers then had to implement. And there were disputes between the two agencies as to how strict the guidelines should be and how well they could be implemented. And this was an issue early on, and it was very controversial even to this day because of the issue of waters of the U.S. and the extent of federal regulation over areas such as wetlands. And when we were developing these two sets of regulations in parallel, we ultimately created daily meetings at OMB with both agencies sitting in the room, working through one set of regulations or the other in order to come out of the process with a common set of understanding for how that would work.
What was the most contentious aspect of it?
I don't know of anything in particular. The most contentious aspect, I would say, would be regulation of farming practices in wetlands, because oftentimes wetlands can be found in a lot of agricultural areas, and so there were questions about what types, if any, of farming practices should be either permitted or allowed to exist on farmland that was also partially wet. And so the farm community obviously then also became very much engaged in that discussion. And so we had the Department of Agriculture very much involved in those discussions as well.
You got looped into the energy scene, what was it, through one of these MIT reports? Was that how you first started really diving into energy?
No, what really got my interest in energy, when I was still at OMB, and this was after the Iranian oil disruption in 1979. And there was an opportunity at that point for me to move from the environmental area over into the energy area. And I became very interested in the energy policy issues, particularly with respect to the oil markets. And so I had an opportunity then to take on the responsibility for the Department of Energy Strategic Petroleum Reserve program. And that program was set up to deal with and respond to disruptions in global petroleum markets.
How come it's not used to just stabilize energy prices over a much longer period of time? We know how bad volatility is for businesses to making decisions. How come we can't just have a giant reserve and fill it up like a capacitor and discharge to just keep prices levelized across decades?
Well, I think there's two reasons for that. One is kind of a philosophical reason, and I think it's fair to say that both in Republican and Democratic administrations, there was a reluctance to have the government interference in global oil markets. Secondly, the market is global, so that even if we were able to regulate what happened in this country, the oil markets interact on a global basis, so we really could not exercise control at a global scale. And thirdly, it would take, just as a technical matter, it would take an extremely large capacitor to be able to buffer a global oil market.
Yeah.
So that issue has never been an issue. The policy has always been to have the reserve as a backstop to deal with severe supply interruptions and ones where of the kind of the embargo type or the embargo scale impacts on the market.
And we're just not worried about that in present day so much anymore because we've discovered so much oil that we have domestically.
Yes, because the markets have changed substantially. If you look at the pattern of petroleum supplies around the world, the concentration in the Middle East is not as great as it once was, and domestic production now is significantly higher. And we've gone through a series of revolutions in domestic production going back to the 1980s and discovery of oils in the overthrust belt, and then into the early 2000s into the development of unconventional oil and gas. And so we now have an abundance, and in fact we've now completely reversed what had been historical policy on oil imports and exports, and we're now a net oil exporter.
And why do we export? Given how important energy is and given how we've seen supply crises affect our country in the past, why don't we just have a rule that all our oil is ours? We can export technology, we can export all sorts of other things that make our economy great, but you know, when it comes to energy, we're just going to hold on to all of our oil.
Because it is a global market. And again, there are limits to what you can control within borders in the petroleum market. And I think economists would say, and I think it's true, that by having an open market results in the most efficient market and the lowest prices for all consumers. So, and I think so looking at it longer term, that kind of a market is the most efficient in terms of pricing. It's also the most efficient in encouraging new investment. Because again, that's also an important factor here in the sense that you want to continue to encourage investment in new development.
Tell us about the MIT energy initiatives.
Well, the MIT Energy Initiative began, I guess, in the early 2000s by Professor Moniz, and he had served in the Clinton administration as Undersecretary of Energy. Was previously to that, had been a professor at MIT, and then went back to MIT and formed the MIT Energy Initiative. And the purpose of the MIT Energy Initiative was really to elevate the focus across campus on energy issues. And the MIT Energy Initiative did that in several different ways. Two ways in particular. One was it was able to raise additional funding to bring in additional sources of funding from private sector sources and philanthropies to support increased energy research on campus. It also was a center for doing technical and policy studies on emerging energy issues. I got involved in the MIT Energy Initiative in about 2007 or 2008 when I was doing consulting work for a large electric utility that had some issues with regard to understanding opportunities for carbon capture and sequestration from existing coal-fired power plants. And there were a very complicated set of issues that they were concerned about, both technical, economic, and policy. And knowing a little bit about the work of MIT, I said, geez, I think that the MIT Energy Initiative is the right place to go to get answers to these questions. So we had a series of discussions between the company and the MIT Energy Initiative people, and we decided on a joint project. And I helped to be sort of the middleman to arrange that. And so when the project got started, then Director Moniz said to me, well, you were involved in getting this thing set up. Why don't you do some consulting work with us in actually running this project? And so that's how I got started with the MIT Energy Initiative. And then over time, my involvement got deeper and deeper. After that, I worked on the Future of Natural Gas study, which was a major policy study that the MIT Energy Initiative did in the late 2000s when it was becoming apparent that the unconventional natural gas was about to become a huge industry. And we were taking a very close look at what the potential would be for both the supply of that of unconventional natural gas, as well as what it would mean for end-use markets. And again, given some of my engineering background and industry, I did a lot of work on that study, looking at questions about natural gas use in industry and what potential demand might be, given the fact that we now had this much more abundant domestic resource.
And how abundant is it?
It's proven to exceed all projections so far. And
where does this natural gas come from? Was this just the decayed matter of organisms hundreds of millions of years ago?
Well, you can find some scientists who some will say that, and some that will say that it might actually be, some of it may be abiogenic in origin, which is basically methane that was associated with the formation of the Earth. So, for example, was watching a program recently on the Apollo program and on the space program, and they were talking about the Cassini probe to Saturn, and on the Saturn's moons there are oceans of methane, and that's not from decayed plant matter.
Right.
So anyhow, but getting back to unconventional natural gas, we knew for many, many decades that there was methane that was trapped in shale rock. And we also knew that conventional oil and gas drilling could not recover that in a economically attractive way. And actually, the original work to identify the resource was actually funded by the government through the Department of Energy going back to the 1970s. And this goes back to after the first oil embargo, where DOE embarked on a major research effort to understand all of the domestic energy resources that we had. So we knew the resource was there, but we didn't know how to extract it. And then it really wasn't till the late 1990s, early 2000s, where a combination of horizontal drilling technology, which had been developed by the oil industry, and hydraulic fracturing, which was also a technique that was developed in the oil and gas industry. Again, some of it with government cost sharing. When you combine those two technologies, you can begin to recover gas economically and in large quantities from the shale resource.
And they're recovering so much that in some places they just burn it, right? They can't even, it is cheaper to just get rid of some of it than, since there's nowhere to put it.
Well, in some parts of the country, there is some gas that's being recovered in conjunction with oil where there's not a pipeline infrastructure. In other cases, there have been production wells drilled that have been taken out of production because of the supply-demand situation.
And how hard is it for us to capture? Now, I understand maybe in coal it's a little bit more difficult to do the sequestration, but if you're talking about a natural gas plant, what are some of the challenges in just mandating that those plants capture their carbon waste?
That's an area right now that's being subject to research. Congress has appropriated some money to do some work in that space. Capturing CO2 from natural gas plants is a little different than capturing CO2 from coal-fired power plants. The concentration is lower, and so it takes more effort, if you will, to capture that carbon. But some of the same technologies can be used, they'll just need to be modified. So our view and some of the work that we've been doing here at Energy Futures Initiative, we believe that there is a significant potential opportunity to capture CO2 from natural gas power plants.
So since you mentioned it, tell us the origin story of Energy Futures Initiative. This came out of your relationship with Ernie Moniz and the work that you've done at the Department of Energy together?
Yes, again, going back to the MIT Energy Initiative days, I was on the staff there, and one of my colleagues there was Melanie Kenderdine, and she served as the executive director of the MIT Energy Initiative. So when Director Moniz was asked to become Secretary Moniz, he asked Melanie and I if we would be interested in going back into government and serving with them at DOE, because he was aware that both of us had previously served in government. So we had prior career experience.
You had a bunch of suits already bought.
Right. So I was prepared and ready to go. So what happened was, during his tenure at DOE, Melanie became the director of the Office of Policy, Energy Policy and Systems Analysis, and I took the position of the CFO. And so after the election in 2016, we were talking about what our future plans might be, and we've had several discussions about, well, we should maybe form a group, an organization to continue the kinds of policy work that we were doing at DOE. And so that really led to the idea of forming the Energy Futures Initiative. EFI was formed as a nonprofit organization. We are kind of a policy think tank. We are focused on finding innovative solutions policy-wise to move to a low-carbon future economy. This builds on a lot of the work that was the foundation work that was done during the Obama administration that led up to the Paris Agreement. And so in EFI, we've continued that work, and I would say the two key hallmarks of everything we do is focused on two things: decarbonization through innovation. And we look at strategies for where technology innovation can lead to new solutions that would be to decarbonize the economy.
And there's two things I want to pull out there. I want to ask a little bit about what are some of the more promising innovations that you've seen, but don't let me forget to circle back and ask, is decarbonizing the economy even enough to prevent climate change? So let's, I guess, start with the first here.
Okay.
So I guess you guys are a research organization. Do you advise on policy as well? Is that part of the mission?
Yes. I mean, we're not an advocacy organization, but we do policy analysis studies. One of our ground rules, two of our ground rules that are very important, is that all the work that we do, we retain complete control over. So obviously we receive funding from various sources, but we control the work we do. And our other major ground rule is all the work that we do is made public. And we promote that work through use of our website, through presentations at webinars, seminars, speeches, congressional testimony, any kind of opportunity we have for interaction with the public and with stakeholder groups.
Okay, so let's talk about technologies. What technologies have you guys done deep dives into?
Well, early on, we did a major study that took better part of a year, that we were very fortunate that we were approached by one of the organizations that was funded by Bill Gates called Gates Ventures.
Mm-hmm.
And they were very interested in having a study done of opportunities in the energy innovation space. And EFI teamed with another firm, IHS Markit, which is a firm that has done a lot of work, particularly in the oil and gas industry. And they had a lot of industry consulting experience. And so together between our two firms, we did a major project where we did a survey of the energy, what we called the energy innovation landscape, where we looked at current policies in that space. We looked at who the current players were, the resource capabilities, where the infrastructure was for innovation across the country, and also what we thought might be areas where what we called breakthrough potential opportunities. And we issued a major report on this in early part of this year. I guess it was in January, and that's publicly available. And in that report, we put together a framework where we said we've identified some criteria to say, here's how we think the government and the private sector should be thinking about identifying and prioritizing new technologies for research, development, and demonstration. And we identified, I think, a total of about 20 technology areas that we thought were ripe for increased investment in innovation that, if successful, could have a significant impact on the marketplace in terms of decarbonization.
What were your favorite? What were your top three?
Well, my top three, I would say, and not in the particular order, but one clearly is advanced nuclear reactor technologies, which is potentially a very large source of carbon-free electricity. A second one, and we touched on it earlier, is carbon capture and sequestration. We have one major demonstration in the US going on right now at a power plant. We have several major demonstrations at industrial facilities, but I think we can do a lot more to improve the cost and the performance of that technology. We also need to do a lot more research on the sequestration side to look at opportunities for how much carbon we can safely sequester, particularly in geologic formations. A third area I think that is very promising is in storage technology. And by storage technology, I mean not only batteries, but other forms of electricity storage. Because again, as the electricity market moves to greater penetration of solar and wind and intermittent generation technologies, there's a need to kind of backfill those valleys. And right now we have the capability with battery technology to have short-term storage, like maybe 4 to 6 to maybe even 8 hours. But we need the technology to be able to store electricity for periods of days, weeks, months, and potentially even seasons. And we don't have that technology today.
But isn't that a little bit of the dog or the tail wagging the dog? If we say, hey, listen, intermittent renewable sources are great, we like them, so we have to have them. But then, and so we're going to account for their carbon footprint in column A. I mean, you're the big financial guy, right? Mm-hmm. And then so now they create a grid that requires some sort of way to balance supply and demand. So now you've got these storage, but we're not accounting for the carbon footprint of that storage mechanism in column A. We're accounting for it in column B. Isn't it possible that we could come up with a situation where we're actually increasing the carbon footprint by requiring renewables, which look like they don't have much of a carbon footprint, but then these battery technologies or even other storage technologies, which the carbon footprint might have originated in the manufacturing process in China or Russia or whoever knows where their chemicals are made, and we pat ourselves on the back because we think we're doing such a good job, but the net global effect is we've actually increased the carbon footprint?
I think, clearly in looking at the opportunities for innovation in storage, whether it's batteries or other forms, you need to look at the entire carbon cycle and the entire life cycle And so those things need to be taken into account. I would say in the case of battery technology, the bigger challenge longer term is if we continue to expand the use of current battery technologies, we would potentially begin to run into challenges with respect to the supply of critical materials, primarily cobalt and maybe to a lesser extent lithium, which is another reason why we need innovation and additional battery storage technologies as well to look at different types of battery chemistries that are more earth abundant, are not carbon dependent.
And is anyone running the calculations on the global scale of the material consumption for if we were to actually do a complete decarbonization of the global economy? Like, we know how much energy the Earth consumes. Let's say we were made primarily by intermittent renewables, and then we also needed the battery backup for this. Literally, how many kilograms of cobalt would that be if the entire world were to be on this system? Is anyone running those numbers? Because I see a lot of projections that are like, oh, if we increase the market share by 50% over the next 20 years, here's what the material consumption would be. But I feel like not enough people are challenging the theory at large. If this is to solve climate change, what is the total global consumption of these materials going to be?
Most of the work that I've seen, as you say, tends to be focused on looking at the sort of the 10 to 20 year projection, and more so looking at the 10 to 20 year projection in the U.S., Western Europe, China, and maybe not looking at what might be happening in the rest of the world. You raise a very good question. I think one is very hard to answer right now, because to look out 40, 50 years, to look at on a global basis, there's an incredibly large amount of uncertainty. That's why I think one of the hallmarks of the work that we do when we develop recommendations in a lot of these areas is one of our important themes in our work is optionality, whereby we are saying that we may not know, we know certain things today, but we're not necessarily saying that we should continue to follow the same path that we're on for the next 30 or 40 years. That's why we need a much more robust program of innovation to develop new options, and then over time it will become clearer which ones of those might be the most appropriate for large-scale market deployment.
One of the things that also challenges me is in the rhetoric around innovation is that it has to be some new breakthrough technology. I mean, even Gates's other organization, the Breakthrough
Energy Ventures.
Right. And obviously our organization is incredibly involved in the nuclear sector. We've met with every startup, read every single report, and we're looking at the numbers that these companies are providing, the advanced nuclear technologies. Their best case estimates, which, as we all know, in technology development is usually much better than it'll actually be in reality, at least for the first few. And then we compare that to the numbers of what was already built in the 1970s with nuclear power plants. And if those exact models were just to be built today in the exact same way with the exact same blueprint, they're 1/3 the price of what the advanced technologies are quoting, and that's their best case guesses. So is it possible that we're just too focused on it has to be new, it has to be innovation, it's got to be a sexy breakthrough in technology, and we're not looking at an incredibly interesting option of just something that's kind of old and people grew tired of?
Well, I think that there's sort of more to the equation than that. One of the things that the two other aspects, I think, to the advanced nuclear technologies that I think are very important. One is safety features. The newer technologies all now embody various forms of passive safety features.
But why is that important? Are we saying that the 99 operating plants in the U.S. are not safe enough?
They're safe enough.
So why isn't that the end of the conversation? Why would we impose additional safety requirements, which surely are going to add cost, if we just said right now the ones that exist are safe enough? Why isn't that the end of the conversation?
I think, well, two things. One is, first of all, I'm not sure that going from active safety to passive safety adds cost. It's different approaches. And if it's done well, it could be done efficiently. I also think there's a larger issue of public perception, which is that I think the just as in any product line, over time, the public is always expecting something that's going to be better. And I think in the nuclear space, I think if we're going to have a new generation of nuclear deployment, we want to be able to say it's better. And I think the other aspect of it as well is I think that some of these newer technologies have the capability to better manage on site the used fuel problem, so that again, it becomes more built into the system. When the current reactors were built, it was assumed that the fuel would be moved relatively quickly from the sites to some form of a storage or repository. While we're storing it safely on site, it wasn't necessarily the original plan. And I think we now need to think about building reactors where at the reactor site would hold used fuel for a longer period of time.
It seems like the cost is very high for only achieving essentially a public perception issue, right? The cost is billions of dollars in innovating something new, waiting tens of years and all the carbon emissions that are going to accumulate over that time period. And this is all to solve a safety issue, which isn't an issue, but just a public perception challenge, perhaps, and a waste issue. And waste, we all know, has never hurt a single person, place, or thing in all of human history. So once again, a public perception challenge. It seems that that is a very, very high cost to wait for new technologies to come around just to solve a public perception challenge, when there are many other ways to solve public perception challenges.
Well, I'm not sure I necessarily agree with your assertion that there's a significant difference in cost. What we're looking at is a very different approach in these advanced reactors, in the sense that they're also being designed to be at a much smaller scale. The reactor design, the light water reactors that were deployed back in the 1970s and 80s were much larger scale, 1,000 megawatt scale, and they were based on the notion of economies of scale. But they were also very much, pretty much customized projects that were stick-built, built primarily on site. What we're now looking at as well with these advanced reactors is technologies that are more amenable to building at much smaller scale and building much more of the components in a factory. And so the opportunity there, just as we've seen in electronics, where you have the economies of mass production and the economies of learning by manufacturing and learning, we're hopeful that we can begin to realize those same kinds of efficiencies in the manufacturing of advanced reactors. So I think the jury is still very much out as to where the economics of these advanced reactors ultimately will land. And
don't get me wrong, I do think advanced reactors, when they finally come around, could have the potential to be much cheaper as well. But what I'm talking about is the cost of waiting. I mean, to fix any price that you want, any cost on your ton of CO2 that you want, I mean, multiplied by the CO2 that we emit just waiting even 1 year to bring a carbon-free technology to market. And there's no way you can ever pay that back with a slightly lower cost per kilowatt hour of electricity. I guess what I'm saying is, yes, let's have these advanced technologies come around, but why isn't it a much more serious consideration to just start building thousands of plants across the world, just like we did with the same 1970s design, and start doing it tomorrow, so we can avert all of that carbon cost that's going to accumulate year after year after year while we wait for new technologies to come around?
Because I think that's really not the trade-off. The real trade-off in electricity markets right now is whether you build anything that's nuclear versus whether you continue to deploy wind and solar, or whether you build new natural gas. And so in the absence of a carbon price right now, and given the substantial, the absence of a carbon price makes natural gas generation very attractive because of the fact that we talked about the large supply of domestic natural gas. And the fact that with respect to wind and solar, they both continue to benefit from a combination of state-level mandates where utilities are required to buy a certain percentage of their power from wind and solar, plus the fact that they both continuing to receive large federal tax incentives. So right now, whether it's an existing 1970s version of a light water reactor or an advanced reactor, both of those would have a great difficulty in competing in the current market.
In the current market in the U.S. But
In
we
the
all know
US.
carbon is a global problem, and the biggest carbon emitters aren't, U.S. is only 15% of carbon emissions. So if we really care about the global climate problem, it doesn't matter if we subtract from the CO2 emitted in Nebraska or if we subtract from the CO2 emitted in India. Why aren't our efforts to start exporting whatever cleanest technology works across the globe and hit the areas that it's easiest to hit carbon first? For instance, it's just the only reason I bring it up is because in all of these reports that I see, the 20 solutions, I just never see, let's go to India and sell 1,000 1 gigawatt 1970s Westinghouse plants, exactly how we built them in the US. The ones that we're still running today, literal copy the blueprint and go to India and build them.
Well, there is interest in building an export market. Matter of fact, I was just part of a task force at the Atlantic Council. We put out a report where we made a number of recommendations for enhancing the U.S. position in export markets where we're basically competing against Russia and China. And for a number of these countries, for example, in the Middle East, yes, they have the potential markets, or some of them do, for large-scale reactors, but many of the other countries may not have the market where they want to build a 1,000-megawatt plant, whereas some of these newer plants at 200 megawatts, 300 megawatts, or even smaller, have a much more potential, better match, if you will, to the market demand. And so I think that, again, we need to be thinking about getting one step ahead of the game here. And I think that's where the advanced reactor program, I think, can be, is very important.
So I promised I'd circle back on it, and that's the second question that always comes to mind. Let's say we even achieved global decarbonization in every sector, industry, heat, transportation, electricity, agriculture, global decarbonization. We were emitting 0 tons of CO2 across the world per year. That doesn't do anything about the rate at which we accumulate heat from all of our past emissions. And even if we doubled it, the rate at which we accumulate heat isn't that much different because we're talking about all of our past emissions here. And so isn't that the much bigger problem to solve? How do we actually get the CO2 that we already put in the air out? And that if we don't address that problem, the practical implications on climate change and how it's going to affect the world, whether it be through drought or flooding, it's just not going to look that different if we, in the timeline, won't even look that different unless we address those previous emissions. So how do we think about that, given that we can't use efficiency to address the previous emissions? We can't use direct, or we can't use capture at the site of the plant to address previous emissions. All of our lowest hanging fruit, which we're barely hoping will get us to decarbonize our future emissions, none of these things can be applied for previous emissions. So how do we think about this problem?
No, it's an excellent question, and you're absolutely right. And I think that in looking at some of the science on climate science, that even if you were to get to a net zero carbon emissions, in the next decades, that there would still be a certain amount of warming that takes place and certain amount of climate impacts. And so really, I think that's really has now opened up the thinking about another potential avenue, which is carbon dioxide removal, which is removing carbon dioxide that has already been emitted to the environment, whether it's in the air or in the oceans. And in fact, it is a new area, and it's one that we are doing a major study project on right this minute. And we are looking at what would be a research and development portfolio of projects to begin to advance opportunities for carbon dioxide removal. There are some things going on in the private sector right now, particularly with direct air capture, at very small scale, and the economics of that are very uncertain right now. And so, but that looks like one potential promising area that needs a lot more innovation. We're also looking at opportunities for how one could begin to capture or to isolate carbon that's already been in the oceans, as well as looking at ways to technologically enhance the natural processes that soils and plants and trees have right now where they capture carbon. That, in other words, not just simply a matter of planting more crops or planting more trees, but can we do research on ways to increase the opportunity to increase root structures to put more carbon into the soil, or things of that nature, or more plants that absorb more CO2 more quickly. So we are actually probably our next major report, because the work that we've been doing on this is close to being finished, will be on this whole issue of carbon dioxide removal. And we see the need for a new federal government initiative for research, development, and demonstration in this space to begin to, again, provide more options on the table for how policymakers can deal with the climate issue.
Yeah, it almost seems like from a first principles perspective, you can derive that is actually the only thing that matters, because if all of our other solutions combined can only address the 40 gigatons of CO2 we put into the air every year, we've got this problem of 1,000 gigatons of CO2 that we have to deal with. We're looking at a problem about 50 times bigger. We should be focused on the problem that's the bigger one. That's where we should be investing our intellect, our energies, our innovation, our research capital, because we're going to have to get to it anyway. And by definition, almost, if we could address all those previous emissions, who cares what the new emissions are? Because if we know how to suck 1,000 gigatons of CO2 out of the air, fine. Let China put their extra 10 gigatons of CO2 into the air, because we've got a solution that actually works for it. It just seems to me that on like a first principles logical basis, that's where all of the effort should go.
I don't think it's an either-or proposition. We really need to be working on solutions for both mitigation as well as carbon dioxide removal. I think implicit in what your question there is, I think, a moral hazard problem, in the sense that if you just simply focused on carbon dioxide removal, then what you're saying is then it doesn't matter what we emit to the atmosphere. And I don't think that is a pathway that policymakers or the public would find acceptable. I think we need to be doing both. And I agree with you that carbon dioxide removal has the potential to reach out to affect the carbon calculus, if you will, on a much bigger scale. But I think we need both, and I don't think we want to take the position that is either or. They're going to have to be complementary solutions.
Joe Hezir, thank you so much.
Thank you.